In this video, we will be talking about graph data structure. This is an introduction video where we'll go over some basic theory behind graph and then we'll write Python code. Here I have a picture of my Facebook network, just a part of it. My network is pretty big. But in this network, what happens is there are nodes which are people and then they are connected via Facebook. Here is my brother, Bhavin, who is connected with me, and then Bhavin might have his own connection. So this graph can be pretty complex. So this is basically a graph data structure. It is an undirected graph because there is no direction between two nodes. Here individual entities are called nodes, and the thing that connects those entities are called edges. One of the utility of graph data structure is Facebook's friend suggestion. So Bhavin is my friend, but Bhavin has some connection, let's say Nikisha. It is likely that Nikisha can be my friend. Hence Facebook will suggest Nikisha as my friend suggestion. This is one of the utility of graph. Another example of graph is flight routes. So here there are routes between different cities across the world. This is a directed graph because there is a direction. There is a flight from Mumbai to Paris, so there is a direction to it, hence it's called a directed graph. Now thinking about this, you might think, what's the difference between graph and a tree? In tree, there is only one path between the two nodes. Here you can see that graph is a complex data structure where you can pretty much randomly connect any two nodes. Thinking about Mumbai and New York, there are two paths which connect these two nodes: Mumbai, Paris, New York, Mumbai, Dubai, New York. In fact, there is a third path which is Mumbai, Paris, Dubai, New York. You cannot have this in tree. In tree, if there are two nodes, there should be only one path. So then, tree can be thought of as a spatial type of graph. Now, one of the common utility of graph is finding the route between two cities. Let's say here in the case of our flight route example, you might go to websites such as like priceline.com, where it allows you to search for flights, or kayak.com. You can enter two city names and it will tell you all the routes between those two cities. How does it do that? So if you're working in Priceline or Kayak or any website like Google Flights, and if you're a backend engineer, you will be dealing with graphs a lot, and you will be given a task to find out the shortest route between two nodes, or maybe all possible routes between the two cities. In case of Mumbai and New York, one path is Mumbai, Paris, New York. The other one is Mumbai, Paris, Dubai, New York. And the third one is Mumbai, Dubai, New York. So these are the all possible paths. But the shortest path in terms of minimum number of stops is probably Mumbai, Paris, New York and Mumbai, Dubai, New York. There could be type of a graph where the edges are weighted. And this weight in the case of the flight route example will be the distance between the two cities. In this case, this is called a weighted graph. And the shortest path based on a distance is not Mumbai, Paris, New York or Mumbai, Dubai, New York. It is actually Mumbai, Boston, Hartford, New York. Although there are 4 nodes in total, but the total distance is minimum. Hence, in this case, if you want to find out the shortest path based on the total distance traveled, it will be Mumbai, Boston, Hartford, New York. There are many other examples of graph that we probably use in day-to-day life. You use Google Maps every day. It uses graph behind the scene. Other example is internet. When you are connected to internet, you are talking to different computers. So there are different servers or different computers in any network. It could be internet, intranet. Those are connected using graph. Basically, it can be thought of as a graph topology. Facebook is the example we already looked at. Amazon recommends the product recommendation using graph data structure and some of the graph theory. Let's write code to implement graph in Python now. During implementation of graph, the first question that arises is how do you represent this class using a data structure? If you think about all these nodes, which are cities, these nodes are nothing but pairs. So if you think about Mumbai and Paris, the connection is basically a pair between Mumbai and Paris. Then similarly, we have pair, which is saying Mumbai and Dubai. And each of these pairs are routes actually. So one way that you can think of is by using tuple. So you can have a list of tuples presented like this. And every tuple indicates one route. Here you have your starting city, you have your end city. And this tuple, using this tuple, I will write a Python class. So the Python class will be called graph. And here in Python, the first function that you write in any class is init. And what I'll do is I will have these routes passed as an input or an argument to this init function. And these are called ages. I'm using a generic terminology here. That's why I'm not calling it routes. I'm calling it ages instead. And then self.ages is equal to ages. So I'm just storing those ages here. And when I create an object of this class, it will be called, let's say, route graph. And route graph is nothing but this, routes. Now we'll be looking at two possible scenarios, which is finding all the routes between two cities and finding the shortest route. So here we saw that between Mumbai and New York, there are these three possible routes that you have. And you want to find the shortest path based on minimum number of stops. You might have seen different website which allows you to do flight booking, where you can specify minimum number of stops, or maybe you can specify two cities and it will tell you all the possible paths. So this is the exact application that we will be implementing, so that once you learn this theory, maybe you can get a job at Google Flights or maybe Priceline. So in terms of manipulating this information in a proper way, what you need to do is you need to transform these ages from list of tuples to some other better data structure, because going through these ages one by one every time whenever you are trying to find a path will be too expensive of an work. But what if we can create this kind of a dictionary where from Mumbai there are two possible paths. So one is Paris, the other one is Dubai. So just imagine we have a dictionary like this, okay, and similarly from Paris there is a Dubai and New York. So from Paris there will be Dubai and New York. So this kind of presentation might be a little more effective, and we'll see exactly how we can utilize this effective representation. So first step we are going to do is transform from this data structure to this data structure. And how do you do that? Well, it's a simple for loop that you can run here. So I will create a graph dictionary first, which will be empty. Then I go through all the ages. So I go through all the ages. This is how we go through all the ages, okay? When it's tuple, you can unpack the tuple in this way so that you get start and end in two different variables. And then when you're inserting this into graph, your key is always the starting point. So if it is this tuple, your key will be Mumbai. If it is this tuple, key will be Paris. Now, first time when the Mumbai, let's say we are processing this record, At that time our dictionary will be blank, okay, and we will not have a key with Mumbai. So what we'll do is if start in graphic, which means Mumbai is already there in the dictionary. Okay, it's not there. I don't want to think about that for now. So let's think about else. So this is the place where you're processing the first record where your dictionary is blank. In that case, you want to insert Mumbai into the dictionary, and the way you do that is by using this square bracket, and then your value will be an array with the destination value, okay. And once you have filled Mumbai and Paris, you know, your dictionary will look something like this after you process the first record. When you get the second tuple, Mumbai is already there, so you come here. What do you want to do now? Well, you want to insert Dubai into your value, which is a list of your end destination. So then this gives you that value, and all you do is append that destination. And I will now print the graph dictionary just to see how it looks. You can right click and run, and you see that the dictionary looks perfect. So from Mumbai you have routes to Paris, Dubai. From Paris you have these 2 routes. From New York to Toronto you have only 1 route. So my dictionary is prepared. This dictionary will be very useful in the other 2 methods that we are going to write, and the first method is get paths. So what this method is doing is take start and end as an input, and it will return you all the paths. Here in this case, between Mumbai and New York, there are 3 possible paths. So we will be getting these 3 paths as a return value from this function. Okay. Now, graph and tree is a recursive data structure, so it makes sense that you use recursion here, because if you think about it, the paths between Mumbai and New York can be found by first finding the paths between Paris and New York, then you find paths between Dubai and New York, and in those paths you append or you prefix Mumbai. Right now we are having just 1 path between these 2. Oh, actually there are 2 paths. So between Paris and New York there is a direct route, and there is Paris, Dubai, New York route. So first let's find those routes. So I find Paris, New York, then Paris, Dubai, New York. Those are the 2 paths. And then I append Mumbai, or I prefix Mumbai actually, not append. And that's a recursive approach. So we need to use recursion for sure. And whenever you are using recursion, remember one thing. You need to think about the simplest case first. Whenever you are writing recursive function, you need to think about the simplest case. Okay, what is the simplest case? Simplest case could be my start is same as my end. So let's say I supply as start and end. If I supply, let's say Mumbai, then my path that I will be finding will be what? So then I want to return Mumbai as my path. Okay, so let's handle that case. So if start is end, start is equal to end, then return path. Okay, what is my path? Okay, so path I need to take as an input argument because it's a recursive function. When this recursive function will be called between Paris and New York, it will be returning Paris, New York, Paris, Dubai, New York. And when it unfolds, or when the stack unwinds, in the call for parent, I expect Paris, New York and Paris, Dubai, New York, and I want to append Mumbai in front of it. So for that reason, I need to take path as an input argument. And path is nothing but path plus start. So path is path plus start. Okay. All right, so if I call it just for Mumbai, let's just call it and see what happens. So here I will say print. Okay, let me say start is Mumbai, end is Mumbai, and paths between start and end. This is a Python 3 format string that I'm using here, and those paths will be in route graph. You want to call the method called get paths, which takes start and end as an argument. It takes third argument, which is path, but it has a default value which is blank. So when I call it, see, I got Mumbai as a path. So for very simple case, it works beautifully. Okay, now let's think about some corner case. So the corner case could be I supply let's say some starting point where I don't have any paths initialized. For example, Toronto. So Toronto is in the graph, but from Toronto there is no flight starting. So there is a flight from New York to Toronto, but there is no flight that is originating from Toronto. So what should happen in this case? In this case, I should get a blank array, which means there are no routes for given start and end. So how do you do that? Well, if you look at this dictionary, the keys are the starting points. So here you don't find Toronto, see? There is no Toronto as a starting point. So I can look up in this dictionary and see if there is any value. If there is no value, return blank array. So I can say if start, which is an origination point, not in graph dictionary, then return this. So now run this for Toronto to Mumbai. See, I get blank. Okay, so for this corner case, it is working okay. Now comes a regular case, which is your recursion. And in your recursion, so what you want to do is to find routes between Mumbai to New York. First, you need to go through, in this dictionary, you need to go through all the routes that are destination for Mumbai. Then from all these routes, which means first I will go through Paris and explore all the routes. Then I will go to Dubai and explore all the routes from Dubai. Okay. So first thing is running a for loop for node in self.graphDict_start. So when I do graphDict_start here, node will be two values, Paris and Dubai. Okay, what do you want to do with Paris and Dubai? Okay, if node not in path, we need to check that if this particular destination has been visited or not, because if it is visited, it will be in the path. So it is, let's say Paris comes, the path right now is just Mumbai because we appended Mumbai. So Paris is not in this particular path. Okay, so then what you will do is you will call this function recursively, because now my question is, okay, how many paths are there from Paris to New York? So I want to get paths between Paris and New York. So Paris is node and New York is end. Okay, and whatever paths you get here, you need to supply this particular path, which is Mumbai, into that. That way you can append Mumbai to it. Okay, so this will be called new paths, and for every path in your new paths, you want to append to the paths. So paths is a variable that we need to create. It is all possible paths, which is a list, and then you want to append that, and then you want to return paths. I hope this is making sense. So here once again, let's go over Mumbai to New York case. So in the Mumbai to New York, when the code runs for the first time, so let's say Mumbai to New York, and I'll just debug it and see. So you can set a breakpoint like this. You can say debug. Okay, and so this is step into my code. Okay, using this button you can go to the code. So now you can see that your path has only Mumbai, and your destination is of course New York. So now let's go over them one by one. Okay, these are the possible paths that you will get. And now first we are visiting Paris. Okay, so from Mumbai there are two routes, Paris and Dubai. So first we are visiting Paris, and when we are visiting Paris, now here in this function you want to get all the paths between Paris and New York. So I will not go over this function inside this function, I will just come out of it. Okay, or if you want to go inside, okay, let's go inside, let's see what happens. So step into, so now I'm on a recursion. So recursion stack is here. Okay, and now the function is being called for start is Paris and end is New York, and you want to return for Paris and New York, you want to get only one path, which is Paris to New York. If you look at this, Paris to New York is just one path. So then okay, we come here. All right, now we got node as Dubai, because actually Paris to New York there are two paths, Paris, Dubai, New York, and Paris, New York. So now we are visiting Paris, Dubai, New York path, and that's one more recursion. So we go into that, and now my start is Dubai, end is New York. So Dubai and New York only one path, so I want to get just one path as a return value. Okay, so now again this is going for New York to New York. So if you do debugging, this kind of debugging helps you to understand the recursion better. So New York to New York is what path? Well, New York to New York will return just New York as an array. So now what happened is we came out of recursion, and my new paths are Mumbai, Paris, Dubai, New York. So that is Mumbai, Paris, Dubai, New York. Actually I could have gone more deeper, but you can do deeper debugging. So this is my final thing. So Mumbai, Paris, Dubai, New York is one path. The other one will be Mumbai, Paris, New York, Mumbai, Dubai, New York. So first we append that. Okay, so let's append that to paths. So you see my paths has the first path, which is Mumbai, Paris, Dubai, New York. Now I want to explore other paths. So how do I do that? Well, you keep on going. Okay, Mumbai, Paris, Dubai, New York. Okay, now I'm visiting the second node, which is Dubai. Mumbai, Paris, Dubai, New York. Okay, Mumbai, Paris, Dubai, New York. That is appended. Okay, it's just going into recursion now we got Mumbai, Paris, New York. So this is Mumbai, Paris, and New York. Okay, so you get an idea. You can just go through the recursion one by one, and recursively it will keep on appending all the paths. And when you run, okay, in the console you see that all the paths are being printed now. All the 3 paths are being printed. Okay, now let's write a function to get the shortest path. And by shortest path I mean by number of stops, not by the total distance, because we are not covering the weighted graph in this video. We'll cover that in the later videos. So right now we want to get shortest distance based on minimum number of stops. For example, here Mumbai, Paris, New York, or Mumbai, Dubai, New York will be the shortest path, and our function will give you one of these paths. Okay, doesn't matter, you want to get a path which has minimum number of stops. So how do you do that? Well, one more function, get shortest path. Okay, start and path is this. Okay, so now I want to implement this function. This function, if you think about it, is quite similar to the previous function. So let's go step by step. Again, this is a recursive function, so you want to think about the simplest case first, which is, let's say if I do get shortest path where the starting point is Toronto. So from Toronto there is no flight, so I should get none basically. So let's do that. So here, if start not in self dot graph dictionary, return none, and let's test it. So get shortest path, my start is Toronto. It will come here, it will not have a key. Toronto is not a key in this dictionary, hence it will return none. So let's verify. You can see it's none, and this is shortest path. Okay, and now what if I supply New York and New York? Okay, in that case you want to get maybe like this, because that's the shortest path, basically just one city. So then okay, if start is equal to n, then what? Return what? Okay, here again I will do the same thing which I did here for obvious reasons, and then I return that path. So now it's New York and New York, run it, and I get this. Okay, now we need to run the same for loop. So it's the same for loop. Okay, so let's run the same for loop. Okay, and here when I am here, I want to make a call to a recursive function which will be get shortest path, because the shortest path between Mumbai to New York is equal to shortest path between Paris to New York, and then shortest path add into that the shortest path between Paris to Mumbai. Hence when I go recursively, I'm always looking for a shortest path between node and end. Okay, and obviously I need to give path as a third argument, and this will be my shortest path. Okay, so now I got the shortest path between, let's say, Paris and New York. Okay, so what do I need to do? So first I need to check if SP, because see, this function sometimes return none, so you want to make sure you take care of that case. And now the first iteration, so let me create another variable called shortest path, which is initialized to none initially, because we don't know at the beginning what the shortest path is. And if this is none, for example, if let's say I don't have any shortest path, then whatever shortest path I get, I want to keep it. but in the later iteration I will have a shortest path. So I want to measure a length of that SP. So what is the length of the SP? So if the path is like this, then the length of the SP is 4, because 1, 2, 3, 4. It is an array of city names. So SP will be array of the city names. So if the length of that is less than the length of shortest path that we have seen so far, then I want to keep shortest path to be SP, and then you return that path. So now let's see the path between Mumbai and New York. So here it says Mumbai, Paris, New York. See, Mumbai, Paris, New York. There is another path which is Mumbai, Dubai, New York, but I'm just returning just one path out of it. If you look at paths between, let's say, Paris to New York, there are two paths, like Paris to New York and Paris, Dubai, New York. So let's try that. Here it says Paris, New York. It did not tell me Paris, Dubai, New York. Alright, that's all I have for this tutorial. I'm gonna link my GitHub for this code in the video description below. So clone that Git code, try to run this code on your own, try to play with it, try to play with different set of route and look at how it goes. I don't have an exercise for this video, but in the future I'm gonna cover graph traversal, and I can create maybe 10 videos on graph alone. So I will be adding more videos on more data structures in the future, and I'll try to cover algorithms as well, and I will have more exercises for you in the future. I hope you're enjoying this data structure series so far. If you have not seen my previous videos on different data structures such as LinkedIn, hash map, and so on, please watch them, and give this video a thumbs up or leave a comment. I'm putting a lot of effort in making these videos, so please make sure you share with your friends if you find this useful. Give it a thumbs up and subscribe to my channel. Thank you.